All right, 1.1 notes. I'm going to start by talking about the coordinate plane. So our coordinate plane, quadrant 1, is in the positive x and the positive y. So we have an x and y axis, where x is positive and y is positive. That is quadrant 1. And then we go counterclockwise from there. So opposite of a clock. Then we move to the left. This would be quadrant 2. Down in the bottom left would be quadrant 3. And then the bottom right would be quadrant 4. The next slide talks about the distance formula and where it comes from. So we're going to be finding the distance between 2 points. It's actually derived from like Pythagorean theorem. On the next slide, we have our distance formula. So the distance between points A and B are the square root of x2 minus x1 squared plus y2 minus y1 squared, where we have 2 points. The first one is x1 comma y1. The second one is x2 comma y2. So we have the distance formula. Example 3, we have to apply the distance formula. It says which of the points P or Q is closer to point A. So the first thing we want to do is find the distance from P to point A, figure out how far apart they are, and then we want to find the distance from Q to point A and see which one is closer. We're looking for the closer one. So let's find the distance. So I'm going to call it distance of P to A. So our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. It always helps to label your points first. That way you know what is getting plugged in exactly where. So I'm going to call P x1 and y1, and A is going to be x2 and y2. It doesn't matter which one's your first point and which one's your second point. Just make sure you're consistent with them. So let's plug them in. So we start with x2 minus x1. We have 5 minus 1 squared. Plus y2 minus y1 would be 3 minus negative 2 squared. So it's 5 minus 1? 4 squared plus, what is 3 minus negative 2? 5. Awesome. This turns into a plus, so 3 plus 2 would be 5 squared. What's 4 squared? 16 and 5 squared? 16 plus 25 is 41. So the distance from P to A is square root 41. We can just leave it as a radical for now. We're going to compare that to our other distance. So what would I need to do next? Find the distance between Q and A. So I'm going to call Q x1 and y1. And then A is going to be our x2 again and y2. So we're going to plug that in. So we're finding the distance between Q and A. So x2 minus x1 would be 5 minus 8 squared, plus y2 minus y1 is 3 minus 9 squared. Juan, what's 5 minus 8? Negative 3 squared, plus, Juan, what's 3 minus 9? Negative 6 squared. What's 3 squared?
9.
And 6 squared?
36.
And 9 plus 36?
45.
45. So with these two distances, which one is closer? P or Q? What's closer to point A? Which one? Why P? Because it's a smaller number. It's a shorter distance, so it's going to be closer. So P is closer. So again, we're finding the distance. Our distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. What's the first thing we should do? Before we plug it in, what should we do? Label them. So I'm going to call it x1, y1, x2, y2. It always helps to label them before you plug it in. That way you just don't get them mixed up. So x2 is 0, minus x1 is 10 squared, plus y2 is 4, minus y1 is 3 squared. 0 minus 10 is negative 10 squared, plus 4 minus 3, 1 squared. What's negative 10 squared?
100.
And 1 squared? 100 plus 1? 101. Always check to see if you can simplify it. Do we have 2 factors of 101? I don't think so. So always check to see if you can simplify your radical. If you can't, then you're done. But if you can simplify, make sure you simplify. Any questions there? All right, let's find the distance between E and F now. What's the first thing I should do? Label them. X1, Y1, X2, Y2. Just makes it so much easier to plug in. Start with X2 minus X1, so 5 minus negative 1 squared, plus negative 2 squared, sorry. So 5 minus negative 2. And then in our second parentheses, we have 7 minus negative 3 squared. All right, Tomas, what's 5 minus negative 2? Awesome. Minus negative 2 turns into plus, so 5 plus 2 would be 7. And then, Tomas, what's 7 minus negative 3? Perfect, 10. Again, it turns into plus, so 7 plus 3 would be 10 squared. What's 7 squared?
49.
And 10 squared?
100.
49 plus 100? 149. Can we simplify this? What are 2 factors of 149? No, can't simplify. All right, last thing we're going to talk about is the midpoint formula. So our midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So the midpoint formula, the midpoint is a point. It's the average of your x's and the average of your y's. Your answer will always be a coordinate point. So the midpoint is a point. So we're going to find the midpoint between the following points. So our midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. It's the average of the x's and the average of the y's. What's the first thing I should do here? Label your points. We have x1, y1, x2, y2. Now we can plug it in. So 17 plus 9 over 2 and 4 plus 3 over 2. 17 plus 9 is 26 over 2, and 4 plus 3? 7 over 2. Can I simplify this anymore?
Yeah.
What's 26 divided by 2? 13 over 1, which is just 13. And then 7 over 2, we can't simplify, so you can just leave it as 7 over 2. You don't need to change it into an improper fraction. You can just, or a mixed number. You can leave it as an improper fraction. Any questions here? Ready for number 2? What's the first thing we should do? Label them. x1, y1, x2, y2. Then we plug it in. So what do we do first? Negative 4 plus 5 over 2, and then?
6. What would it be, minus?
You could say 6 plus negative 1, which would be 6 minus 1, so it doesn't really matter how you write it. So 6 plus negative 1 over 2. What's negative 4 plus 5? 1 over 2. And what's 6 plus negative 1? 5 over 2. Can we simplify either one of these?
No.
No. So that would be our final answer. So the first 5 from the homework are just simplifying the radical, so you just have to find the factors. The next 4, you have to find the distance and the midpoint of all 4 of those, so leave your answer in a square root, but make sure it's simplified. For the last 3, you're given an endpoint and the midpoint, and we have to find the other endpoint. So we're working backwards here. So let's call our midpoint, we'll call it just x, y. That's our midpoint. Our midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. So we're going to use our midpoint formula to set up 2 little equations to find the x that we're missing and to find the y that we're missing. We have to kind of work backwards here because it gives us the midpoint. It gives us the answer. We have to find our x2 and y2, really. So this we can call x1, y1, and then our midpoint we'll call x and y. So we're going to start with just the x's first. So I'm going to use my x's from the midpoint formula, and that's equal to the midpoint. So x, our midpoint, is equal to x1 plus x2 over 2. Now what's this big X going to be? Just X. What do I plug in there? 3, because our midpoint is 3. So that's equal to, I'm going to plug in x1, so we have 5 plus x2 over 2. So I'm solving my equation here for x2. What would I need to do to solve first? Awesome. We're going to multiply both sides by 2. So 3 times 2 is 6. That's equal to, when we multiply the right side by 2, the denominator cancels out. So 5 plus x2. What would we do next? Subtract 5 on both sides. So 1 is equal to x2. That is just our x value. We have to do the same thing to find the y value. So now we need to find the y. So we're going to say y is equal to y1 plus y2 over 2. What am I going to plug in for my y? 1, because the midpoint is 1 for the y. So 1 is equal to, what's our y1? 7 plus y2 over 2. What would we do to solve here? Multiply both sides times 2. So 2 is equal to 7 plus y squared. What do we do next? Subtract 7. So 2 minus 7 would be negative 5 is equal to y2. So our other endpoint, our x2, y2, would be 1 comma negative 5.